Have you ever wondered how the food in our body converts into energy? How medicines cure illnesses? Or how fuels help in driving vehicles? Answer to all these and similar questions is a single word: chemistry. Chemistry is the branch of science that deals with the study of the composition, structure, properties of matter, and changes that matter undergoes. What is matter? Anything that has mass and occupies space is known as matter. Before we learn more about matter, it is important that we know the importance of chemistry in our daily life. It is interlinked with other branches of science and plays an important role in our daily life. How important is it in our daily life? Let's explore. Chemistry plays a major role in identifying the weather patterns, manufacturing fertilizers, alkalis, acids, salts, dyes, polymers, drugs, soaps, detergents, metals, alloys, other inorganic and organic chemicals, and new materials that contribute in a big way to the national economy. Meeting human needs in producing food, healthcare products, and other materials aimed at improving the quality of life. Producing superconducting ceramics, conducting polymers, optical fibers, and large-scale miniature of solid-state devices. Synthesizing safer alternatives to environmentally hazardous refrigerants such as CFCs, chlorofluorocarbons, responsible for ozone depletion in the stratosphere. Understanding biochemical processes and the use of enzymes for large-scale production of chemicals, and synthesizing of new materials, which have extensive uses in various fields. In order to understand the applications of chemistry in different fields and benefit from it, it is important that we know about matter. Based on the arrangement of the constituent particles, matter can exist in three physical states: solid, liquid, and gaseous. Let's look at the description of each state along with their characteristics. In solid state, the particles are held very close to each other in an orderly fashion. Hence, there is not much freedom of movement. They have definite volume and definite shape. In liquid state, the particles are loosely held together and can therefore move around. They have definite volume but no definite shape. They take the shape of the container in which they are placed. In gaseous state, the particles are far apart as compared to those present in liquid state. Therefore, their movement is easy and fast. they have neither definitive volume nor definite shape, and they occupy the available space of the container in which they are placed. The three states of matter are interconvertible by changing the conditions of pressure or temperature. For example, on heating, a solid changes to liquid. Liquid, on further heating, changes to gaseous state at normal atmospheric pressure. Similarly, in the reverse process, gas on cooling changes to liquid, and on further cooling, liquid changes to solid. Matter can be classified as pure substances and mixtures based on the chemical composition. Substances which contain only one kind of atoms or molecules are called pure substances. And in a pure substance, the composition of a substance is fixed. For example, carbon dioxide is a pure substance which consists of only molecules of carbon dioxide, and it has carbon and oxygen in a fixed ratio. When elements or compounds are mixed together in any proportion, it results in the formation of a mixture. Thus, in a mixture, the composition varies. For example, seawater comprises of dissolved salts and water. The seawater consists of varied amounts of dissolved salts and water. Pure substances can be further classified into elements and compounds based on separation of it into its respective constituents. Substances which consist of only one kind of atoms are called elements. Examples of elements are sodium, copper, silver, hydrogen, oxygen, etc. An element cannot be further separated into its constituents by physical or chemical means. For example, oxygen consists of only oxygen atoms, and it cannot be further separated into its constituents, that is, oxygen atoms. Two or more elements combine chemically in a fixed proportion to form a compound. Examples of compounds are ammonia, water, etc. A compound cannot be further separated into its constituents by physical means, but can be separated by chemical methods. For example, oxygen and hydrogen are present in a 1:2 ratio by volume in water, and water, that is H2O, can be separated into its constituents, hydrogen and oxygen, by electrolysis, but cannot be separated into its constituents by any of the physical methods such as distillation, fractional distillation, etc. Also remember that the properties of a compound are different from those of its constituent elements. For example, the elements hydrogen and oxygen, being gaseous in nature, combine to form a compound, water, which is a liquid. Mixture can be classified further based on the uniformity of the particles present in it. If the particles are distributed uniformly throughout the solution, then it is a homogeneous mixture. For example, sugar solution is a homogeneous mixture because sugar particles get distributed uniformly throughout the solution. If the particles are not distributed uniformly throughout the solution, then it is a heterogeneous mixture. For example, sand dissolved in water is a heterogeneous mixture because sand particles are not uniformly distributed throughout the solution. A mixture can be separated into its constituents by physical methods. For example, a mixture consisting of iron filings and sulfur powder can be separated by using a magnet, that is, by magnetic separation.